Hey everyone, and welcome back. If you're into AI, music, or maybe both, you're in the right place. Recently, I took part in the awesome Kaggle 5-day Gen AI intensive course with Google, and for my capstone project, I decided to teach an AI to compose music. Specifically, I wanted to see if I could fine-tune one of Google's Gemini models to generate traditional folk tunes, not just as abstract ideas, but in a specific musical language called ABC notation, and then turn those into MIDI files we can actually listen to. So stick around as I walk you through how I fine-tune Gemini, the challenges involved, and the surprisingly cool results. First off, what's the challenge here? Well, generating music isn't like generating plain text. ABC notation, commonly used for folk music, has its own grammar, headers for title, key, meter, and a specific way to write notes and rhythms. Our goal was to get the AI to understand and create valid ABC notation, and then convert that into a standard MIDI file, the kind you can load into almost any music software. The core idea was to use supervised fine-tuning. Instead of just prompting a massive model, we'd show it hundreds of examples of real folk tunes in ABC format. We used the ABC notation examples folk text file from the ABC notation of tunes dataset on Kaggle. Big thanks to the uploader for making that available. Now, the most critical step before tuning was data preparation. You can't train an AI on bad data. I used the Python library Music21 to parse every single tune. If Music21 couldn't understand it, the tune was discarded. This ensures we're only teaching the model valid patterns. Then we format the good tunes into this simple input-output structure that the fine-tuning API expects. With clean data ready, it was time to fine-tune. We used the Gemini 15/001 tunable model. This part of the code, heavily inspired by the Day 4 course notebook on fine-tuning, kicks off the tuning job on Google's backend. It takes our examples and adjusts the model's parameters. This process runs in the background and you monitor it until it succeeds. It can take a little while, so patience is key. Alright, moment of truth, we now have our fine-tuned model. Let's ask it to generate a new tune. We use a simple prompt asking for an original song, returning only ABC notation. And look at that, it generates text that looks like ABC notation, but we're not done yet. We run the generated tunes through Music21 validation again to catch any mistakes the AI might have made. We also added a quick check for musical plausibility by seeing if Music21 could analyze its key. Finally, the valid, plausible tunes get converted into MIDI files. So what do these AI-generated folk tunes sound like? Let's load one up. Here's one of the MIDI files loaded into Ableton Live. You can see the notes generated by the AI. Pretty cool, right? It definitely captures that folk-like feel. We also checked, and these weren't just copies of the training data. The model learned to generate novel variations. Of course, it's not perfect. Fine-tuning depends heavily on the input data quality. ABC notation itself can't capture everything MIDI can, like dynamics, and our evaluation was basic. There's much deeper musical analysis we could do. But this opens up cool possibilities. Imagine training it on classical music, or maybe even rendering the audio and using another AI, like in Google AI Studio, to generate album art based on the sound. This capstone project was a fantastic way to explore fine-tuning Gemini for a creative task. It showed how we can use techniques like MLOps, structured generation, and evaluation to build something unique. A huge thank you to Kaggle and Google for the Gen AI intensive course. If you want to dive deeper into the code and the process, check out the links in the description below for the public Kaggle notebook and the accompanying blog post. Thanks for watching, let me know what you think in the comments, and I'll see you in the next video.